Okay, hi guys. So in this video lecture, we'll be talking about halogenation. So we'll be seeing the reaction of benzene with chlorine, bromine, iodine, and we'll be also looking into the reagents we'll be using with each of the following halogens. Okay, so let's get started. So we'll be discussing off with halogens or other halogenation. Okay. So we have something like a benzene ring, okay, and we pass it on Cl2 in presence of AlCl3, second Br2 in presence of Fe, and third I2 in presence of HNO3. So what do we get in each of the reaction? We'll get simply benzene substituted with halogen group. Okay, and let's actually discuss the mechanism of these reactions. The mechanism is something like, in the first step we have something like Fe, and on reaction with Br2 gives FeBr3. Okay, and in the next step what actually happens is we have something like Br2 which on again reacting with, okay, first let me draw the benzene ring. What actually happens is we have this benzene ring, and we have Br2 which actually comes in contact with FeBr3, okay, and acquires a partial positive and partial negative charge, and as a result the phenyl ring would actually attack on partially positively charged bromine atom, and we'll get something like this as a rhenium ion, Br and H here, okay, plus we get FeBr4 minus, okay. In the next step would be getting something like this H would be breaking up the bond between itself and the carbon atom to which it is attached, and as a result obviously Fe minus would be actually attacking on the hydrogen atom which is getting released with the bond with the carbon bond as a positive charge, and as a result there would be a negative charge on this carbon and positive charge on the neighboring carbon atom. So we'll get something like a benzene ring restored in the compound or in the reaction, and we get HBr plus FeBr3. okay, so this is how the mechanism works. Okay, and similarly we can do this for the other reagents as well. And one thing to remember in this reaction is we have Hi also produced as a side product, okay, and HNO3 is actually used so that Hi is oxidized and becomes I2. So HNO3 is used as an oxidizing agent for Hi to be removed from the reaction. Okay, so let us actually see some of the characteristics of this reaction. Characteristics are, first, that the Lewis acid used in the above reaction are all anhydrous. Okay, like example we used AlCl3, FeBr3. okay, so Lewis acids, example AlCl3 and FeBr3 used in the reaction are anhydrous. Okay, second point is it is better to prepare Lewis acid in the reaction mixture. That's why we are using directly Fe in rather than FeBr3. Okay, so it is experimentally determined fact. Okay, so it is better, the second one, it is better to prepare Lewis acid in the reaction mixture. Okay, we have third point as the role of the oxidizing agent in iodination is to destroy the HI formed in the reaction. Okay, when we were talking about this reaction, I also told previously also that in this reaction HNO3 is used as an oxidizing agent to remove HI from the reaction. Okay, so in this reaction I2 in presence of oxidizing agent HNO3, we get I attached or substituted to the benzene ring and we get HI. So as to remove this HI, we used HNO3. Okay, so let me write this down formally, that the role of HNO3 or rather oxidizing agent in iodination is to destroy the HI formed in the reaction. Okay, and as I have also written in the previous video lectures that kinetic isotopic effect is observed in case of sulfonation and iodination. So I am going to repeat that statement here again, as we are saying halogenation or specifically iodination in this lecture. So I am just writing it again, that kinetic isotopic, theoretically we can say that even sulfonation and iodination should not have any kinetic isotopic effect, as that was not there in case of nitration, but this is a experimentally determined fact. So we have to just remember the fact as of now, because some indirect or external factors are there which are actually changing or which are having or introducing the kinetic isotopic effect for the given reaction mechanism. So kinetic isotopic effect is observed in iodination. Okay, so now let's discuss some questions. So we have the question like, you have to identify the products or specifically major products from the following reactions. So identify products. Okay, so first reaction is, we have something like this, and NH here, and we react it in Br2 in presence of Fe. So obviously this is a anhydrous. Okay, Lewis acid will be FeBr3. Okay, then FeBr3 would actually attack on Br2, so that Br plus and Br minus would be formed. Br minus hence formed will be attached to FeBr4 minus. Okay, attached as a FeBr4 minus, and Br plus would be used in aromatic electrophilic aromatic substitution reactions. So we have to determine at which position the Br plus will get attached. Obviously this is a deactivating ring, but this will actually, this carbon atom, the nitrogen atom attached to the carbon atom also have a lone pair, hence it is a orthodirecting and paradirecting. Okay, so we would get something like this. Okay, let's see another example. Herein we have a chlorobenzene. Okay, it reacts with Cl2 in presence of AlCl3, what will happen is this will act as a Lewis acid. Cl plus would be formed, and as a result you would get something like this product and this product. Okay, obviously this would be a major product. Why? Because steric hindrance can be seen because of two bulky Cl groups. Okay, let's look at third example, wherein we have something like a benzene ring and it is getting attacked with this and in presence of AlCl3 to get to product A, and A product again reacts with Cl2 in presence of AlCl3 to form product B. You have to identify product A and B. Obviously product A would be simple Friedel-Crafts alkylation is going to take place here. So what we can say is this would be the product A, and when Cl is again acting on it, the B product, if we have to identify only one product, then we would go with the para product, because this compound and Cl, if attached on ortho position related to the alkyl group, then steric hindrance is can be seen to be present. Okay, so if we have to identify only one product, that is B, so we'll go with the para. Okay, just let me erase it for better understanding. Okay, so now let us do fourth example. Herein we have something like this, ICl in presence of AlCl3. What would be the major product? Major product would be simply iodine. Why? Obviously iodine is less electronegative than chlorine, hence partial negative charge would be on chlorine and partial positive would be on iodine. So with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples and we'll be seeing some more reactions as well. So till then, good luck and goodbye.